All right, in section 3.4, we're going to talk about solving equations using logarithmic and exponential functions. This is a 2-day section, but there's only one video. The reason it's 2 days is it's such an important skill for us to be able to use the rest of this year in ACT and next year in calculus. The key to solving with logs and exponentials is remembering that they're inverses of each other and that one will cancel out the other. Just like if you had x plus 5 equals something, we'd subtract 5 because plus 5 and minus 5 are inverses of each other. Multiplying by 3, dividing by 3, squaring something and taking the square root. Any two functions that undo each other help us solve, and logs and exponentials will do that for us here. So we've started with a few exponential equations here that we want to solve without a calculator. Well, the first one I made intentionally really easy because you should be able to tell that 2 to the third power equals 8. But I wanted to point out that we can use a log to cancel out an exponential. So if I've got 2 to the x power, and I'm trying to get that x down to where I can solve for it and get it by itself, taking the log base 2 of that side will make that happen. And obviously I need to do that same thing to both sides to keep the equation equal. But the log base 2 of 2 to the x power, those cancel each other out and just give you x. And then our answer is the log base 2 of 8, which again we know is just 3. So our answer would just be 3. Right? So if we have 2 to the x equals 19, a number that we don't immediately know is a power of 2, using these logarithms helps us more. Take the log base 2 of both sides. Whatever the base of your exponential function is, you take the base logarithm the same, so they'll cancel each other out. We do the same on this side, that cancels, and we get x equals log base 2 of 19. Without a calculator, there's not much more we can do. With a calculator, we could evaluate that. I guess we could also write it a different way without the calculator. I'm just thinking about multiple choice, ACT or something like that. Remember your change of base formula? You could rewrite this as the log of the argument divided by the log of the base. You can use natural log as well. You could say the natural log of 19 over the natural log of 2. Right? Any of those ways to write that are going to be fine. If you had a calculator, one or all of these would help you evaluate that and get a decimal for it. Okay? No matter what your exponential function is, take the log of that base to cancel out the exponential. So if you've got e to the x equals 37, well, remember that to get rid of an e, we do the log base e. We know that is natural log. We know that is ln. The ln of e to the x power, those cancel out, just leaves you with x. And so our answer would be ln of 37. It's totally okay to leave your answer like ln of 37 or log base 2 of 19, because without a calculator, there's nothing else we can do. It's like leaving your answer as the square root of 2 or the square root of 5. Just without a calculator, we can't simplify that anymore. So if you've got an exponential function, you can use a logarithm to cancel that out because they're inverses of each other. What if your equation has logarithms in it? What if I'm doing the log base 2 of x equals 6 and I'm trying to solve that? We can cancel out a log with an exponential. And the way you do this is by taking this log base 2, by taking the base of 2 and turning your whole equation into exponents. So I'm going to put the 2 down here and the 2 down here. So the 2 to the log base 2 of x, that cancels out and just gives you x. And then 2 to the 6th would be your answer. 2 to the 6th, which I think without a calculator we can eventually get 2 to the 6th to make it 64. Right? Hey, Mr. Reinhardt's here. He's going to teach some math. You want to teach, do ln of x equals 2?
Yes.
All right. What do you do, Mr. Reinhardt?
Well, because a natural log has a base of e, I would do a change of base, and I would exponentiate both sides. And
That's the exponentiate is what we did here.
There we go.
Both sides of the powers.
I use big words on here. So e to the ln of x
Yeah.
equals e to the second power.
All right.
Now, when you take e to the natural log of x, they will cancel each other out, and you will be left with x equals e to the second power.
There it is, x equals e squared. Thanks, Mr. Reinhardt.
You're welcome. Cameo appearance.
My Mr. Reinhardt impression is really good, you got to admit. And the ventriloquism, too. So e squared is the best you can do. All right, x equals e squared is your answer without a calculator. With a calculator, we can type it in, we get a decimal. But e squared is perfectly fine there. And Mr. Reinhardt's right. That's called exponentiating both sides, if you like big math vocabulary. Raising both sides to a power, using that base as your exponential function on each one of those. Okay. Finally, two more examples, one without a calculator, one with a calculator. Without a calculator, we've got the log base 2 of 5 plus the log base 2 of x equals 4. Before we use that 2 to raise to powers, we need to simplify this side. We're going to do that using the properties of logarithms we learned in the last section. Remember that if you're adding two different logarithms and the base is the same, you can multiply the arguments. So this could become the log base 2 of 5x equals 4. Now I can use my 2. You do 2 to this power, I can do 2 to this power. 2 to the log base 2, those cancel each other out. Leaves you with 5x. Over here, 2 to the 4th power is 16, and so then you solve for x. 16 over 5, 3 1/5, 3.2, however you like to do that. So we don't need a calculator there either. Just got to remember your properties of logarithms from the last section. Now if we did have a calculator, I just wanted to mention one that we could actually type in there. There's nothing different about this equation, and we could solve this without the calculator. It's 2 to this power. The log base 2 will cancel out that 2. Log base 2 on this side. So I've got x minus 3 equals the log base 2 of 53. Now if I didn't have a calculator and I wanted to get x by itself, I just add 3 to both sides. So my answer would be 3 plus the log base 2 of 53. If you didn't have a calculator, you could leave the answer that way. If you do have a calculator, then you may see decimal answers, like in a multiple choice situation, ACT or something like that. So I'm going to type in 3 plus, now I've got an old calculator, I can't type in log base 2 of 53. So I've got to do 3 plus log 53 over log 2 in my calculator. If you've got a newer calculator, in that math menu you can do a log base, and that'll speed things up for you. We got 3 plus, I'm going to do log 53 over log 2, 8.728 if I round that up. And that would be my answer. That's one way I could do this problem. I could also just use the graph. If I could graph 2 to the x minus 3 power. I could graph 53. I could find the intersection of the two. So my point there is if you've got the calculator, you don't have to solve this by hand. You don't have to go through all these steps and get this decimal answer. You could choose to graph both sides and find the intersection, and that's perfectly fine on an ACT or something like that. So big idea. Logs and exponential functions being inverses allows you to use one to solve for the other.